Starting from example 5, things gets a bit more complex because you will see fraction. So fraction is the one that you need to remember. Square root is a half. Then cube root is a 1/3. So these are the more common fraction. Okay, and the thing is you are also dealing with negative fraction. Whatever is it, as long as the power is negative, you need to get rid of negative first. If you need to get rid of negative, you're going to go back to rule number 7 and rule number 8. Okay, so that is the one that you're going to take note. So it will get a bit complicated. Okay, so you just have to train your brain. So part A is actually quite easy. Part A is 49 and power half. So which represents square root 49. So that will be a 7. Or some students, right, they will present it this way. They know that 49 is actually 7 squared. So there are some students, 7 squared, sorry. 49 is 7 squared. So some students will change it that way. And then they use the double power. So that will also give a 7. So both ways are correct. It's your choice. So the next one, we start to get a little bit more complex. The fraction, the power is negative. So again, right, if you ignore the fraction, this is negative for a whole number. So it is negative power for a whole number. So I should be using the rule number 7. So in this case, rule number 7 will let me make it into a fraction. And without any negative, 1/4 is the 4th root. So where it is the 4th root, you can do it this way. And you will get a half. Or some students, right, they will do it this way. They will change a 16 to 2, 4. So if you do that, you are also correct. You will still get a power 1. So you still end up with a half. So if you are the one who change a 16 to 2 power 4, so you are doing the 4 times 1/4 double power. So that's getting the same number. For part C, we are looking at a non-negative power. But the numerator is not 1. So we want to simplify the 2/3. So I'm going to simplify the 2/3 into 1/3 times 2. So essentially 2/3 is 1/3 times 2. So in a way, it's the same thing. We pull the numerator up. Pulling the numerator out will leave you with the power 1/3, which becomes a cube root. So a cube root of 27 is 3. So that's how you get a 9. Okay, so I'm going to erase this part. D, I'm dealing with a negative power again. So let me erase everything here first. So make sure you have copied. So if you do your part D, it's a mixed number. The negative is for a fraction. So the negative is for fraction. So I'll be using rule number 8. I'll be using rule number 8 to get rid of the negative. So first of all, it must be a proper fraction first, improper fraction. So that will be a 16. Then I can flip over. After the flip over, that is a representation of a square root. So if you need to get rid of negative power, you always go back to 7 and 8, even if it's a negative fraction power. Okay, then what about E, where you got a decimal? That is 1.5. You can see as 3/2. So again, if you see as a 3/2, the numerator is not 1. You pull the numerator out. That will give you a half, which is a representation of a square root. So you get a 125. For part F, we also have negative power. We also have fraction power. But what I can see is this looks like a same base division first, same base multiplication. So I'm going to do a same base multiplication first. Then I'm going to do a same base division. So I'm going to subtract. So I end up getting a 3/2. So I'm going to be, that means if I end up as a 3/2, it's going to behave very much like E, where I can pull the numerator up and end up with a square root. So I got same base multiplication, I got same base division. Then I use my rule number 10 to pull out the numerator. So number 10 and number 9 and number 10, somehow they are linked. Okay, so let's look at more complex one. So when things become more complex, sometimes the basic rules are still applicable. So for example, this is a negative. This is a negative power for a fraction. So I should be using number 8 to flip it over. And then 1/3 is a cube root. So you can cube root the number. For the numerator, I didn't want to cube root because it's an algebra, so I will do a double power. So if I do a double power, I will get 9 times 1/3 over 4. So that is x cubed over 4. Okay, then for part B, that is a fifth root. So essentially, if that is a fifth root, the power is 1/5. So do recognize that it's actually 1/5. So you can actually do it like this. The fifth root of 32 and a fifth root of x cubed. So the fifth root of 32 will be a 2. Then what about the fifth root of x cubed? Fifth root is 1/5. Then you apply the double power, you get a 3/5. So it's 2x to the power of 3/5. Okay, so things start to get complicated. So make sure you will copy first. If you look at parts C and D, okay, we're going to mix things up a little bit. Okay, so in the previous one, I think the previous example, I did mention that the double power can always be used, even if it's the fraction power. So in this case, right, if you take a look here, this is a cube root. So that means, right, it will be a power 1/3. Okay, and then this part, you can make it a double power first. So be 1/4 times 2/3, 4 times 2/3. And we can choose to make it into a huge division. So this part that is divided, I'm going to put it at the bottom. So you can always punch calculator for this. So you will get 1/6. Let me just make sure the 1/6 is correct. So this one you get 8/3 this part. So I'm still doing this, I'm still going to be doing the same base division, despite that it's a fraction. Doesn't matter. So I will get a 2/3 minus 1/6. I get a 4/3 minus 8/3. So I just punch my calculator. So I get a half. Then this one I get a negative. So you need to get a positive index. So this one is negative for a whole number. So you should engage your rule number 7. So I'm going to engage my rule number 7. I will get a 1/. My final answer will look like a big fraction. Power half over 4/3. So as long as positive index. Okay, so for part D, I would like you to be trying. Part D is exactly the same method as C. Okay, so you can apply a double power first. So do a double power for these two fractions. Okay, this is my hint to you. So this is a double power. So make sure there's no bracket first. And then because of the divide, make it into a huge fraction. So once you make it into a huge fraction, you can do this kind of grouping. Then you can use the same base division. Okay, so you give it a try. If nothing goes wrong, your answer will be y³ over x. So you give it a try and let me know. How did you fare? Did you manage to get the answer?